Okay, so before we actually create any instances or go into configuration, let's actually see the EC2 Instance Types available. If we just Google that, it'll be the first non-advertisement link up here. And then we get a page that I'm sure a lot of you have seen before, listing all the millions of options you have in EC2 Instance. There's really so many. What I want to do is show you what they are at a high level and give you some of the conventions here so that you might know what G versus A versus N and Z and all that good stuff, what those conventions mean that AWS gives when they're naming their instance types. Now, first and foremost, the high-level types are here on the left: general purpose, compute, memory, accelerated. All this stuff is sort of obvious. General purpose are the most common and have some of the cheapest instances, and they're very general in that they don't have specific things going on with them. For example, the compute optimized are CPU optimized, so you'll get more CPUs and maybe less RAM. Memory optimized are more RAM and perhaps less CPU cores. General purpose here is the most common and often is where you want to start. You might want to just start using general purpose instances and get a feel for if your application needs anything specific. How you go about deciding if your application needs some specific thing like more compute, more CPU, more memory, a GPU is very specific to your application and something I'm not really going to talk about because I'm not qualified to talk about that. Profiling your application will be something you kind of have to figure out to see and decide if you have a bottleneck in your server that might be resolved by using a different instance type here. But let's just go over the high level things. So general purpose includes Macintosh. Macintosh is sort of its own little thing. It's a bare metal server only, so you get an entire server. It's not a virtual machine, and it's very expensive. Then you have the T4s, T3s, T2s, the M series, and the A1. Now, the T series are often the cheapest, or they are the cheapest, but they also work on a system of CPU credits, which will be the topic for my next video, so I won't talk about that too much here. And then you have the M-class instances, which do not run on a system of CPU credits and are a little bit more expensive as a trade-off. You have compute optimized, and these ones will give you more virtual CPUs, vCPUs, and generally you get a little bit less memory than you might for a memory optimized, well, definitely for memory optimized and a general purpose as well. Now you can see we have a bunch of options here, right? So instance size, so it's the name, how many CPUs, how much memory in gigabytes. The instance storage, EBS only, means you can attach an EBS disk. This is basically normal. When you add storage to your EC2 instance, you're just adding an EBS disk. And you can add one, which will be the root drive where all the system files are, or you can add more than one and you can mount those and add data to them and all that good stuff. The ones that have NVMe SSDs additionally still let you add EBS drives, but they also have extra SSD drives that are places that you can access faster storage. In other words, you mount these, they are not the root drives, so you mount these as additional drives on top of the EBS drive that is a root drive. And you have faster storage, but they're ephemeral, which means if the server gets shut down, the data on them is lost. Network bandwidth. So you actually have network bandwidth constraints on the server, depending on the server size. So the larger the server, the more network bandwidth in terms of gigabytes per second that you are allowed to use. Some are up to, and some just have a steady amount. And then EBS bandwidth. So EBS disk drives are not pure disk drives. They actually work over the network. So they have their own bandwidth as well. So you can see these are up to. So EBS drives tend to have some burstable bandwidth. So up to 4750 in terms of megabytes per second. And some of these have a set amount, not just up to as well as you get to larger instances. Okay, so that's compute optimized. They have generally faster and more CPUs. You can read the description here to see a little bit more about them, the type of CPU, and why they are generally better than other things. So example, C5, C5A, C5N, all are optimized for compute. You can have more CPUs, you can have better CPUs and all that good stuff. Memory optimized are optimized for fast access to RAM. Accelerated computing has GPUs, in other words, video cards. Storage optimized have very high bandwidth for EBS drives, as well as NVMe drives. And those are basically the high level categories. Now, more interesting or perhaps more confusing are all the different types here. So you have R5, R5A, R5B, R5N, all this good stuff. Let's go ahead and just look at some of these to see what they might be. So first off, up here, anytime you see Gs, it means they're Graviton processors, which means it's going to be an ARM-based CPU instead of AMD-based. So ARM-based will be ARM processes, and AMD-based will be something like an Intel or an AMD-based server. Regular ones that don't have a modifier like A or G or N are just kind of the regular instances. A instances are AMD based instead of Intel based. So, right, we have ARM instances that are G for Graviton. T3A are AMD based instances and typically are cheaper with a trade off of slightly reduced CPU power for using an AMD chip instead of an Intel chip. Gs are also cheaper, and I think they're typically the cheapest to use ARM based instances, although they're not necessarily slower. There's just other things that have intrinsic cost savings to them, and so they pass that on to us. We have the same thing here. M6 is Graviton. M5 are the standard general purpose instances. M5A is AMD based. N is a new one here. N is for network. So network performance. So typically you'll see better network performance out of instances in the N series. Then we have Z here. Z here, this is also ZN. So this also has a higher network throughput. But Z is also, in this case, I think for Xeon scalable processors is what the Z is for, if I'm not mistaken. But typically, these have CPUs that benefit from extremely high single thread performance and high throughput. So M4 is just basically M5, but older. So you just want to start at M5. And A1 is AWS's very first ARM-based instance. They called it A1. Okay, so we've covered a few modifiers, G, A, N, and Z. There's a few more we might find down here as well. R5B, for example, is one. B stands for block storage, I believe. So EBS optimized. So this instance are for EBS optimized variants of memory optimized R5 instances. These increase EBS performance by 3x compared to the same size R5 instances. Okay, so R5 are in memory optimized, and some have a variant of B for increased EBS performance. So this is probably really good for databases. Something like MySQL that writes to the disk very often and also might use up a lot of RAM. So that might be a good use case for a memory optimized workload that needs to speak to a disk drive very quickly. Okay, so that's all I want to cover there. We see we have some naming conventions here. In addition to the high-level server types, we also have some conventions around the modifiers, G, A, B, Z, N, D, all that good stuff. They have different meanings, and if you keep those in mind, I'll list them out in the notes below this video. You can get a good idea of what the server is off the bat without really having to dig too deeply into it.